Hi everyone, welcome back to the 2018 exam question rundown. And in this one, we're going to be having a look at questions 9 through 15 in the calculator assumed section in the exam. Now, as always, or as I mentioned in the previous one, you do have access to the formula sheet as well as your own notes. And I would encourage you to make some of your own notes as it's incredibly useful to making sure that you understand stuff. So basically, if you find a question that you find interesting, then if you can write a worked solution of it, just to give you an idea of exactly how to go about solving it. Okay, so let's get going. Now, question 9, we've got the graphs of a few parabolas. We've got y equals 2x squared plus 2x plus c. We've got one that's y equals a brackets x minus 2 all squared plus 1. And we've got y equals x plus b, x plus 3. So we should be able to tell from the graphs down here which one is which. And what we're going to need to do is to work out the values of a, b, and c for this one. So let's start by working out what's what. So this one here is going to be the easiest one to start with. This means it's got a turning point at 2, 1. So let's find 2, 1. There it is. If that is our turning point, that means that this is our blue line right here. Let's try and write that a bit more smoothly. There we go. So that is our, that's that parabola there. So what's A going to be? The first thing we need to know, or we'll recognize first off, is that A is negative. Otherwise, the graph will be pointing up like the other two. As it goes, so another thing we can try is what happens when x is equal to 0. If x is equal to 0, we've got negative 2 all squared, or A times that, plus 1. And we can see here that it's going to be 0 there. So we basically got 4a plus 1 equals 0, which means that a is negative 1/4, which tracks because we were expecting it to be negative because it is pointing down. So we can quite straightforwardly say that a is negative 1/4. I think this is going to be the next easiest one to work out. So let's have a look here. X plus 3 over here means that it's got a y-intercept or an x-intercept at negative 3. So where's our other one? Next x-intercept is at, there it is. So our next x-intercept is at 1, which means that B is just going to be straightforwardly negative 1, because that's the thing where we'd end up with 0 there. That's all we need to do for that particular one. Let's just sort of fix up that line a little bit. That's all we need to do. That's a very easy one to work out. Very easy mark there. And the last one here, 2x squared plus 2x plus c, that by deduction has to be this line over here. And it should be extremely easy to work out what c is, because this is just going to be the y-intercept, which is negative 1. So c equals negative 1 as well. So we've got negative 1/4, negative 1, and negative 1 for our three answers for A, B, and C. And all of that is actually really straightforward to work out. We just got to remember what we're doing. This is when x equals 0. The c is going to be our y-intercept there. Okay, so that's that there. Now we've got a circular graph. What is the equation? So we've got a graph of a relationship. We got to determine the equation of this circle in this form here. X squared plus y squared equals a plus bx plus cy. So the first thing we'll recognize is the center of this circle is at negative 2, 1. So, and the radius is 1, 2, 3, 4, 5. Radius is equal to 5. So we should be able to recognize that we've got x plus 2 all squared plus y take 1 all squared equals 25. So if we've got that, because this is calculator allowed, I'm just going to write that in my calculator. X plus 2 plus y, take 1. I've got to do the square, obviously. And I'm going to do action, transformation, expand. Our calculators are good at expanding this stuff. And that'll give us x squared plus y squared and plus 4x, take 2y plus 5 equals 25. Let's start to translate these over. That'll become 20 on the other side, plus 2y, and this will be negative 4x. X squared, oops, let's write that x a little bit neater. So x squared plus y squared is negative 4x plus 2y plus 20. So that is actually really easy to work out. We can expand these if we want, but remember that our calculator does have the ability to expand, and in all honesty, we should be making as much use of our calculator as we can if it's going to sort of make it easier for us to work these things out. Okay, so next up, the line x plus y plus 1 equals 0 intersects the circle at points A and B. Show that line passes through the center of the circle and hence determine the distance AB. Let's just line this up. So we've got the 3 marks over there. So first, what line is this? It is the line y equals negative x take 1. So let's have a look. Negative x take 1. It starts at there. It's got a gradient of negative 1. So I can draw that through there. There we go. Pretty straightforward. It does go through the center. You could say that by referencing the graph, or we could say the center is at negative 2, 1. We substitute that in. 1 equals negative of negative 2, take 1, equals 1, as required. Okay, intersects the circle at the points A and B. So it intersects the circle at 2 points. It doesn't actually matter where these 2 points are. We've got a straight line here. What's this? This is the diameter. We know that that's the diameter because it goes through the center. It's a straight line. So the length equals 10. It's always going to be 10. We don't have to calculate it because it's just the diameter of the circle, and we already know the radius is 5. There we go. Easy. Now, next up. A thin pole stands vertically in the middle of a level playing ground. We got to draw a sketch, so I'm going to start that here. So we got our thin pole. That's not very vertical. Let's get that a bit better. Here we are. From point A on the ground, the angle of elevation to the top of the pole is 18 degrees. Let's try and get that. Where are we? So, there's point A. It is 18 degrees. From point B, also on the ground, but 5.35 meters further. So we got B a little bit further out. Let's try and draw that. The angle of elevation to the top of the pole is 15 degrees. So there we have it. We've got 15 degrees there, 18 degrees there, and we've got a distance of 5.35 meters, and that is our sketch. So we've just got that information and we've accurately drawn this sketch. Now, showing use of trigonometry, determine the height of the pole. Now there are 2 ways to do this. We could work out this, see, this is a triangle itself, and we've actually got enough information to work out all the information related to this triangle. From that, we could work out the length of the top bit there. So let's do that. I'm just going to throw this all into my E-activity. So what we've got here is this triangle here. Oh, let's actually draw it so it looks not terrible. And what's this angle going to be here? That is going to be 162 degrees and 15 degrees and 5.35. So what's the other angle up here? This is going to be just 3 degrees, or we could go 180, take 15, take 162. And that will give us just our 3 degrees at the top there. So this is going to be a tiny little angle up there. Let's go back into our E-activity. And what we're going to try to solve, I've got the wrong little E-activity in there. So let's just get the proper one in there. That's the applications one. Let's get the methods one in there. There we are. That's the one we're after. So, now, this is going to need, the reason why I did that is because we're going to need the sine rule. And I'm going to put my, my acute angle in there of, where are we? Come on, let me write in there, 162. This opposite is the one we're finding. We've got a distance of 5.35. and an angle of 3 in there. So we solve that. 37. Oh, that's negative. That's not what we expect. So let's just double check. We've got to make sure we've got it in degrees. Let's calculate that again. And we get an answer that makes sense. 31.58. So this is going to be 31.59. We're going to round it to using solver. It's totally okay to use solver for this sort of thing. And now what we've got is we've got a very straightforward right-angled triangle, don't we? So we know this is 31.59. This is 15 degrees. So that is just going to be, and we're trying to find that side on there. This is our sine one, so sine 15 degrees is opposite or x over hypotenuse, 31.59. So I'm going to take this, and you can actually do this. You just go edit, copy, and I'm just going to go edit, paste if we don't want to get the wrong number, times sine 15, and that gives us x equals 8.18 to 2 decimal places. Now just remember when it comes to decimal places, if they haven't told you how many decimal places, just match the data you've already got. That's to 2 decimal places, so we can do that to 2 decimal places. And remember to include your units there. So that's an easy way to do that one. Another way we could have done it was to set up some simultaneous equations, but we're not going to bother with doing that. I find this one a bit of an easier way to go about it, but I'm sure there'll be more opportunities to set up simultaneous equations later. So 8.18 meters, that seems about right, I would say, based on what we see, because it's a bit, I mean, my diagram's not going to be perfect, but it does seem to be in the realm of possibility there. Okay, now, we've got f of x is that, g of x is that, which is a little bit different. The graph of that is shown below. So, something that's important here, what do we got? Okay, that's g of x, so this is our one here, and this, so that's g of x. So we want to graph f of x. Now, one of the tricks to graphing these is to try putting in different values of x in there. So let's have a look at what we expect this to do. Now, our standard parabola, our standard reciprocal function looks like that. But this one, when is the underside going to be equal to 0? It's going to be equal to 0 at 3. So it's going to have a vertical asymptote there. What else is going on? The other thing that's going on is that there's nothing being added to our number. So there's nothing being added to this at the end, so it's not being shifted up or down. So it's going to have a horizontal asymptote at x. So one of the best ways I like to try and work out what's going on next is to just try the x values at 4 and 2. What happens when x is equal to 2? That's going to be 4 on 3 minus 2. What's that? 4 on 1, which is just 4. So we expect to be at 4 here. What's going to happen at x equals 4 on the other side? 4 over 3 take 4. That's going to be 4 over negative 1, which is negative 4. That's going to be our y value for that. So that is going to be that on the other side. We know this is an asymptote, so let's just draw it in. And that is roughly what we expect it to look like. One of the things we can always do with these, if you want to try and sketch them, just substitute values that you know will give you easy answers, such as the ones that are to the left and right by 1 of where we expect the vertical asymptote to be. Now this one has technically been flipped upside down, because, and that's because we've got subtract x in there. So this would actually be adequately represented by negative 4 on x take 3. It's sort of been hidden that we've got this negative 4 on the top, which flips it upside down by the fact that the signs of the bottom two numbers have been reversed there. So that's what we've got there. And so yeah, what's the values of P and Q? All we need to do is work out which way these have been moved. This has been moved, we find the middle point where it would normally be, and this has been moved to the left by 2 and down by 3. So down by 3 means Q is negative 3. Left by 2 means that P is 2, because when we add 2, we move to the left. If we were subtracting 2, we'd be moving to the right. So yeah, that's pretty easy. And you can always try, if you really wanted to, remember this is calculator allowed, 4 divided by brackets 3 minus x. I can pull up my functions, and I'm going to do just some defaults there, and I can drag that into here. And if I'm careful, I can see basically exactly where my points are. So it's clear that we've got a 3 there, and we've got some good grids here. So we go across by 1. Yep, 2, 4 is one of my points, and 4, negative 4 is another one of my points. So we can see those points on there if we have a look at the graph when we put it on the calculator. So that's something we can do as well. Remember, the calculator is a great little tool, so you can always use it to work out your answers. Okay. So, in fact, let's do this one now. We want to solve the equation of where that one equals the other one. So let's do exactly that. So that is going to be 1 divided by x plus 2. And then we add, or subtract 3. Let's put that one down here. What's going on? It's gotten itself mixed up. It's never done this before. Oh, I'm just going to kill that, and then we will load it back up again. This can happen with your own ones as well. Let's just see here. This is inconvenient. Come on. There we go. It's dead now. Let's bring it back to life. If your calculator does freeze up like that in the exam, always in an emergency, you can, I think there's a reset button on the back. Probably don't push that though, because it may sort of do a bit more than you want. You can always just pull the batteries out of the back, plug them back in, if you do get in that sort of situation. But let's try that again. So that is going to be, and I'll write it as a proper fraction, 1 over x plus 2 minus 3 is one of our equations, and the other one was 4 over 3 take x, and I'm going to do the default setup. There we are. Okay, perfect. So I did it properly this time. This looks exactly like we expect it to. And so let's solve that. We go to analysis, gsolve, intersection, and we can write those ones down there. So what are our intersection points? And remember, we're only interested in the y value because we're trying to find, we're interested in the x value, not the y value. X equals negative 1.7, and then we can push across to find the other one, or 4.4. And so this is really just do you know how to use your calculator to find intersections and how to enter all these graphs in and everything like that. And that's not too hard to do. Okay, there we go. Next up, axis of symmetry for this one. Remember that the axis of symmetry is always negative b over 2a, which means it's negative 12 over 2 times 3, which is negative 12 over 6, which is negative 2. There we are. So that's going to be our axis of symmetry, x equals negative 2. We can always test that. Let's have a look. 3x squared plus 12x. Remember, this is calculator allowed, so we can just do this. Let's throw that in here. Where are we? Looks like, there we are. It's a bit higher up than I thought it would be. So yeah, at x equals negative 2, that's where our turning point is. That's going to be our axis of symmetry there. Okay, fantastic. Not a hard one to do. The difficult bit is if you were trying to graph it, then it would not necessarily end up being something you could easily see. So the graph of this passes through those 2 points. What's the values of constants a and b? This is actually a very straightforward simultaneous equation problem. We've been given x and y values for both of these. So we just need to use the simultaneous equation solver. We want to do negative 23 equals a times negative 3 all squared plus b times negative 3 plus 13. And the other one is 4 and 5. So we got 5 for our y value is a 4 squared plus b times 4 plus 13. So that is under keyboard. This one here, this sort of parentheses, curly brackets. And we always want to do whatever our variables are in here. So I'm going to do a comma b. I'm actually going to use those letters. So negative 23 equals, if you go to variables, we can do a. It's always got to be the one under italics. That's when you push these x, y, and z's on the keypad. It'll do the right thing. Negative 3 all squared plus b times negative 3 plus 13. Hopefully that'll all be good. 5 equals a times 4 squared plus b times 4 plus 13. And then we got a comma b in here. A is negative 2, b is 6. Easy. So all this is really about is constructing it's asking you, do you know how to construct a simultaneous equation in your calculator? If you do, this one should be absolutely straightforward. And this sort of skill will help you out because there's often like 2 or 3 questions that involve this skill or are helped by knowing this skill. Okay. So a logo with a triangular outline contains a shaded segment. We've got that line there and then a circular arc, blah, blah, blah. Let's label up the things we know. Radius BM equals 18 centimeters. Angle ABC is 5 pi on 12. Let's turn that into degrees, shall we? 5 pi on 12 times 180 divided by pi. That's 75 degrees. But we have got the radians version if we need it. BCA is 2 times BAC. So this is theta. This is 2 theta. And M is the midpoint of BC, which means that this is going to be 18 centimeters on the other side as well. So what's the size of ABC in degrees? Oh, I just did that, 75 degrees. Great. What's the area of the shaded segment? So this is just going to be using our class pad. Where are we? This is going to be in e-activities. And we're trying to find just the segment area. So what have we got? We're trying to find the area. We've got the radius was 18. Remember that this needs to be in radians for this to work. If it's not in radians, we'll get the wrong thing. So we've got to do 5 pi divided by 12. This is just a property of our of what we've got for the equation for solving this. Because our theta is outside of sine, it needs to be in radians for it to work properly. So let's solve that. 55.57. Or 58 centimeters squared. Just let's check. Yep, these are centimeters, so it's going to be 55.58 centimeters squared. Just using the solver, and it's totally fine to just use the solver for these things. It's only 2 marks, so that's all good. Perimeter of the shaded segment. Okay, that's going to be a bit harder. So the radius. So basically, it's going to be the chord plus our arc. So the arc was. So the arc there is 5 pi on 12, I think it was. Was that our arc? Yeah, 5 pi on 12 times the radius, which was 18. Let's just double check that. So yeah, that's just, and if we really want to do that, we can just solve that in there. So the length of that is, I think it's already got it there. So that's going to be 23.56. And the chord length, I think we've got that down here. Where is chord length? Oh, we don't have chord length in here. Anyway, we can find the chord length easy enough. That is just in the, where are we? In here. length of chord is 2r sine half theta. 2r sine. Is that right? Let's just double check. 2r. Where are we? Length of chord 2r sine half theta, or theta on 2 will do the same thing. So let's put that in here. 2 times 18 times sine. We're in radians. Or are we? No, we're not. We're in degrees. Radians. 2 times 18 times sine 5 pi on 12. And then we can just divide that by 2. That'll give us the right answer, even though it looks a bit ass backwards, but that's all good. That is 21.91. We add, or 915, so 92 is probably a more accurate thing to say. I'm going to add that to our 23.56. And that's 45.48 centimeters. So that's going to be the perimeter of the shaded segment there. And it makes sense because the length around the edge over here is going to be a little bit more than the length across there. The length across there we got as 21.92. The length around the edge we got as 23.56. So that's a little bit longer. Not heaps longer, but enough to sort of make up for the fact, or make up for, or to meet our expectations there. So now area of that triangle, what have we got here? Do we know these angles? Well, yeah, we do. It's going to be 180 equals 75 plus 3 theta. So 180, take 75, divided by 3, 35 degrees. So this is 35 degrees, this is 70 degrees. Easy peasy. So we know that. So we can just work out the area of that triangle because and let's just get back in here. What do we need to do that? We do the area of a triangle. We need 2 sides and the angle between them. So let's work out one of the sides. It doesn't matter which. Let's try and work out AB. So we're going to try and work out AB. According to this, we're going to use the sine rule. So AB is this distance up here. Our angle there is 35. Our distance there is 36, is the one opposite. I'm going to make sure it's in degrees here because that's what I'm working with. I want to find this one over here. So this is going to be 70 on this side. And we're trying to work out the opposite side there. And let's just have a look. Let's try a different number. Let's try this again. So 35. So the angle is 35. That distance is 36. That one is 70. Oh, oops, wrong way around. That should be the unknown. This one here is 70. I got these the wrong way around. It obviously couldn't find it. So let's just check I got those. 35 is our angle, 70 is our angle. Yep. 58.97. 978. So I'm just going to call it 98. So now we know 2 sides and the angle between them. So let's go to our area of triangle. They've dragged in that number there, so that's good. Oh, they've kept that one there as well. The angle at the top is 75. We can solve for the area, and it is 1025. Now, obviously, you need to do a bit more working. It's just a bit hard for me to do while scrolling between them. And with area, this is 4 significant figures. So as far as I'm concerned, that's already more accurate than anything else we've got. So I'm just going to leave it as that. That's going to be 1025 centimeters squared. And yeah, that makes sense. From what I've seen, this one was 55 and this is 1000. It's about 20 times as much area in this triangle than there is in that little divot there. So that seems about good. Okay, so this is the last one I'm going to be doing. Now I remember doing this one in class. It looks confusing, but it's easier than you think. So let's just look at it one by one. Sine of AX. This is going to be a sine wave, which means it starts at 0. And it's going to have a maximum amplitude of 1 because it's not being multiplied by anything. So there's only one graph that fits this one here. I should note that what we're doing here is we're trying to find A, B, C, D, E, and F. So what we want to do is we want to realize how long is its period. Its period is 180 degrees. Normally it would be 360, so this number is being multiplied by 2 to stretch to be able to do it in a smaller space there. Next up, we've got B cos of X. This is just going to be standard cosine. So basically it's going to be starting at some number. It's going to have a period of 360 degrees, but we can't really find where it starts. Let's have a look. Now it looks like, well, this one is where we'd expect cos to be, but it's on the opposite side. So what we've got is B must be -4 because that flips it upside down. And then that would ideally have a period of 360 degrees. So 360 degrees before where it gets back to where it started, which it does indeed right there. Next up, tan of CX. We are looking for a tan line that is at 0 when we are we're in the starting point. And the tan wave usually looks like this. So it's usually like that, something like that. All that's happened is that its period has been changed. So let's look for one that does something like that. Looks like we've got one here. That looks like it there. Now the normal period of a tan wave is 180 degrees. This one's changed to 360. So basically it's been halved. So C is going to be 1/2 there. There we go. Next up, D sine X. Basically, we just want to find a normal sine wave. Here it is. And this sine wave has been multiplied by 5. So D equals 5. Next up, cos EX. We're finding a normal cos wave with an amplitude of 1. We've got that quite straightforwardly here. What's its period? Period is 90 degrees. Normally it's 360, so it's been multiplied by 4. So E is going to be 4. And the last one is a tan wave, which I'm going to do in purple. It's been multiplied by some number. What we want to do is to find out what happens at 45 degrees. Because at 45 degrees, we would expect an answer of 1 for our tan. Remember that tan is also the gradient. So if we got 45 degrees there, we would expect it to be at 1. It's at -1. So F is equal to -1 instead. So that's that one there. That one's not too hard, even though this does look like a confusing mess when we first see it. But we can still sort of look at it logically, work that out, and slowly but surely get all of our answers. And you don't have to do them all in the same order. You can decide, okay, I know what this one looks like, or I know that this is very clearly a sine wave, a very standard sine wave that's been multiplied by 5. I can cross this one out very early, or other things you might spot as we go through it. So we got those there. Next up, calculate the acute angle in degrees between these lines. Y equals x plus 5, y equals 3x plus 1, 3x minus 1. rounding your answer to 1 decimal place. So these are going to be 2 lines. One has a gradient of 1, the other has a gradient of 3. And so that's a rough diagram. It doesn't matter exactly where the y-intercepts are, because the angle is going to be exactly the same no matter what. So, but just remember that what we need to do is that tan theta, and that's not this theta, by the way. I'll get rid of that theta there. Tan theta is our gradient, or rise over run. So what we've got here is we need to do inverse tan of our gradient, and that's equal to theta. So what's our gradient of the first one? Well, it's just so inverse tan of 1. We should know this. This is 45 degrees. So our first line, as we should all be able to recognize, because it's just a gradient of 1, goes across by 1, up by 1, that's 45 degrees. What's our second one? It's going to be inverse tan of 3. That's going to go up a little bit more like that. Let's get back over here. Where are we? Inverse tan. Did I set it up? No, I did not. Okay, if you need to get to inverse tan, it's under keyboard. Trig inverse tan of 3. I want to go in degrees. That's 71.56. Yeah, or 57 rather. We want our final answer to 1 decimal place. So we've got 2 angles here. One's 45 degrees. One's 71.57 for the whole thing. So what we got to do is do that number, subtract 45, and that gives us 26.6 because it's asking for 1 decimal place. So 26.6 degrees is our answer. So that is all pretty straightforward when it comes down to it. So that's what we'll be stopping at for now. That's questions 9 through 15. And I'll be doing another video to do 16 onwards. Usually the tail end is where the questions get really hairy. So if you are sort of, I don't know if I put that down there, here we are. So if you are wanting to just make sure you understand those more difficult questions, do make sure you look at the 3rd video as well. Anyway, I'll leave that there for now. Hope you have a good day, and good luck in the exams. Bye.